Alright, day 2. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole. Gleefully exclaims a nearby sign. Got it. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here. As you make your way through the surprisingly extensive selection of one of the clerks recognizes you and asks for help. As it turns out, one of the young elves was playing on a gift shop and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you'll need to check. The ID ranges are wrapped here for legibility. Okay, so they're one big line. So we have some range of numbers. A lower number, a higher number. The ranges are separated by commas. Okay, each range gives its first ID, last ID separated by a dash. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits. Repeat it twice. So 55, 5 twice, 64, 64 twice, 1, 2, 3, 1, 2, 3. Would all be invalid IDs. None of the numbers have leading zeros. Okay. 101 is a valid ID that you would ignore. Okay. So this is okay. Okay, so obviously the hard part about this, so yeah, adding them all up is okay. The hard part about this problem will be, going through is probably bad. Right, let me have a quick look. Well, okay, I'm thinking like numbers like this. There's a few million iterations, so going through them is not ideal. So there must be some form of pattern that we can find. Right, so we could brute force and then continue thinking about it. Might be a good idea, to be fair. We go through the beginning to end, brute force, and whilst it is doing that, we think of a better solution. Yeah. Okay. I'm using Go for today. So I have a little bit something set up here already. There. Okay. So I'm just gonna run watch go run. So it's just gonna run every 2 seconds. So whatever you see on the right might be a little bit odd. Okay, so let's just go and say line's gonna be os.read file. Reads the entire file, so it's input input.txt with an error. If error is not equal to nil. os.exit 1, and then let's just go fm2 print line error. Yep. Then we have the actual lines. Let's say split lines equal to strings dot split string of lines on sequence new line. Is there a strings.trim? Yeah, let's do this here first. It returns just a string. Cut set trim returns a slice of a new string of s. Cut set. Not sure what cut set is. Anyways, let's just okay, what do we have here? Okay, that looks fine. Let's get some data. Let's write some data structure now. So let's go type range, which is lower, which is an int, which is an int as well. I think is at least 32 bits. So I'm guessing this is going to take whatever my system default is, so 64. Okay. let's go. Ranges split lines. So let's go. Let's go range. Let's go string range. Strings that split line on the dash. Oh, actually, oh, I don't need to read the lines. The lines are going to be one long thing. So actually, we're going to read it and we're going to break on the commas. That makes more sense. We're going to then split on the dashes. And then we go ranges, make, let's go I here as well, make an array of this with the length of these split lines. And we go ranges at I equals range, lower string range 0. Let's go lower string conf-atoy, which one was it? Let's forget. String to int, okay. Upper I usually don't do this type of style with the errors, different names. I usually just do them straight out in line, but I want to kind of minimize the amount of code here. Okay. We exit. Let's just print, both. Okay. We can actually go do a little trick. There you go, initialize that in place. Oh, there's the new line at the end. We don't like that at all. So let's go trimmed string, string of lines, strings dot trim. Maybe this works with this. Let's see. Golang trim, remove the line. I'll remove this trim suffix. I mean, I guess. Oh, my bad. Yeah, that was the example, so it was not quite right. Let's just run this manually a little bit. So we have this error parsing range. There's a space. Oh, I think that's actually my mistake again. No space. Oh yeah, when I joined them together. Yeah, okay, good, that's working now. We can go back to this. Okay. Good. And we can do that, so that's working. Okay, good. We have that in a structure. And now for part 1, we doing this inclusively, I guess? Oh yeah, we are. Inclusive ranges. We can what can we do? Well, we can log 10 to find number of digits. Yeah, okay. Yeah. Or no. Okay, yeah. I can't think of a clever solution right now. There definitely is a clever solution. But okay. Part 1, 0, 4, range of range, I can't do that. Range of ranges. We go for I is equal to r dot lower. So I is smaller than or equal to r dot upper. It's not higher, let's go upper. Yeah. And I plus plus, we go based none of digits is equal to math dot log 10 of like 64 of I. Not that floor. Let's go base 10, and then let's go digits math dot floor base 10. And we actually convert that back to an int. Let's go here now. fm2 print line digits, and then fm2 dot print line part 1 printf actually. There we go. Part 1. There. Okay. Good. This is all making sense, I think. Okay. That's the number of digits. That number of digits for the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hold on. Yeah, I think it's off by 1. Which kind of makes sense. Like if you do 12, log 10 of 12 is 1 point something like this. So actually, yeah, you have to add 1. Good, it's working. So now what we're gonna do is we're gonna do bit shifting here. So let's go. I don't know how to name these things though. So let's go 1 bit shifted over by the number of digits. Is this the mask or the cap? Let's go cap. And let's say lower half is going to be I and cap. And actually that's the upper half, isn't it? No, so say you have like 1 1 1 1 0 0 0 number of digits. Oh, hold on. Yeah, number of digits is then not gonna be quite the same because it's we're dealing with binary. So we would have to count in. Yeah, no, this would still work, right? Like, it's actually interesting because I need to now. Let's delete that. Let's go to this. Cap is always 4. This number of digits is that. And the n is going to be the I ANDed with cap, and we try and print that. So 0, no good. Never mind, this is silly, I think, because why don't I just divide it by something? So if I have, say I have the number 2424, the number of digits is 4, so actually, what's log 10 2424 It's gonna be, it's like 3. Well, it will give me the number of digits, which is 4. So if I then divide that by, you know, like, if I divide that by 10, this is gonna give me 24.24. If I divide that by, no, sorry, there. So I need to divide by 10 times number of digits, or 1 times number of no, 1 to the power of number of digits. No, that's not right. 10 to the power of, or actually sometimes a 1, right? So, oh, that'll be to the power of 0 then. Yeah, okay, never mind. So, number of digits, if it's 0, that's fine. Digits minus 1, that's actually going to be our exp. And we're going to take I. Let's go the upper half. It's going to be x divided by, and this is going to, actually it's going to give us the floor by default because it's an integer, by exponential. Let's go like divisor. It's going to be 10 to the power of x, and then this is going to be I divided by divisor. And now let's have a look at what we get. I think we should have something we can work with. Okay, so we got 1. Let's go for the number 2424 dash, I don't know, 4040. Uh, 269. That doesn't seem right. Let's go I first, and then let's go divisor, and then let's go that. So I is 2424. The divisor is 9. What? What? That doesn't make any sense. Oh, this is an XOR. That's an XOR, not a. Never mind. 10 power of this, exp is, no, power of 10 returns 10 to the power of n of exp, and let's go, we can go straight, actually let's go straight into here, follow the pattern we do above, 2424, the divisor is too big, so exponents divided, take away 1. 24, yeah, 24, 24, 25. Does it go over 25 on the right boundary? It does. Nice. Lower half, which is just it's like a cap, so this would probably be some binary stuff. Remained. Oh, yeah. Yeah, that's silly, isn't it? I think it's a mod. You mod it on the numerator and numerator, yeah. Okay, so you go I mod divisor. Yeah, that's right. Yeah, of course. Duh. Yeah, sorry, that was stupid. Okay. And we get 1, 2, 3, yeah, because that's, yeah, okay. Bruh. Big brain fart. Of course. Oh, I might edit that part out. Okay, let's keep going. So now we have the upper half, and all we have to do, this is still the brute force approach, by the way, which is not a good sign. Basically, if This is the sum of all of them, all valid like this. So if upper half equal to lower half, part 1 plus or equal to, well, just any of them, either of them works. Let's go for this one that we have to be a little bit careful with. Find a space, replace it with nothing. Ah, well. Did it do that already? Oh yeah, it did that already. Wait, that's not right. That's not right. That should have iterated like loads of times. Yeah. Upper half, lower half. Okay, so clearly we're doing something wrong. Let's see which one. So this one has 99, which would be true. Ah, great. Okay. We're printing upper half, lower half. The upper half is 95. Okay, that's not right. Is that right? See, that's more correct, I guess. 99. Actually, yeah, actually, it's the two joined together, so it's going to be upper half times, well, plus upper half. Yeah, 110 for this one. But then, is there an edge case with numbers like this? No, right? It just works. Yeah, 33. No, 33? Why is that 33? 1, 1, 2, 2. Oh, no, that's right. Yeah, that makes sense. Let's... Wait, why does it break for... Well, I was doing something super stupid, which was forgetting to divide by 2 on the exponent. So I was just dividing by the whole thing. So if we had a number like 2424, I was dividing by 1000. So yeah, the upper half was always a single digit, and then the lower was the rest. So, because, yeah, that's... Okay. Stupid moment. Over 2 here. And also, we need to not times by 10 in the same way. We actually need to times by the thing we divided by. The divisor, I think. If I think about that correctly. 1, 2, 2, 7, 5, 5, 4. Yeah, perfect. Okay. Good. Good. That should do it. I wonder if you even have... You definitely have like some clever solution, but that ran very, very quickly. Okay, good. Let's continue. The clerk quickly discovers that there are still invalid IDs in the ranges near list. Maybe the young elf was doing other silly patterns as well. Now an ID is invalid if it is made only of some sequence of digits repeated at least twice. So at least twice. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 2 times, 1, 2, 3, 1, 2, 3, 1, 2, 3. At least twice. Okay, I see. Okay, so this obviously makes it harder. Like we have to split this in some more interesting way. So we no longer have just upper half, lower half. We have to divide by... Okay, actually, I don't think it's too bad. Imagine you have this here. The smallest thing you can do is 2. So you can see the pairs. So you can do this 3 times. So the divisor would be 3. I think. So let's go back to this. Probably gonna do this in a separate part here. It's kind of similar, to be fair. Like, it's really similar in the sense that we can solve part 1 if we solve part 2 correctly. So, okay, so we need like another loop here that goes through the number of chunks we're chunking our number into. And so we can always go from 2 and actually this only ever works with even numbers, right? Like, we cannot possibly have a repeat with odd numbers. So okay, so yeah, that's something good. So first of all, base 10 of this. Good. So we have number of digits, right? Or like close to. Let's Matplotlib that straight away. Then this is actually digits. Great. So if digits mod 2 is not equal to 0, we continue. So I wish I had, you know, nice little chaining syntax instead. Okay, mod 2, we continue. And now just, okay. And now, well, we have to go between 2, 3, 4. So if we have the number 1, 2, 3, 4, we can only go between 2. So we can only go between the max of digits divided by 2, which is equal to 2 in this case. So imagine we have the number 1, 2, 3, 1, 2, 3. We can go 6, 2 equals 3. Okay. Okay, we're getting somewhere. That's good. Let's go like chunks. Chunk size. Let's go digits over 2. Let's go 4. Digits over 2. What if we have 10? 2 over 2, 1. The chunk is 1. Yeah, the chunk can be 1. So I guess 1, 2, 3, 1, 2, 3. I mean, I guess. Oh, if it's 1, 1, 1, 1, yeah. Okay, well, okay. Let's go chunk size between I. J is equal to chunk size, whilst J is smaller than. Sorry, not chunk size. 1 smaller than or equal to chunk size J++. Yep. Nice. And now that we have this, we can do the same thing we had before, which was take and divide by this. Ooh, but we have a lot of things to divide by. So, so we're going to divide by 1. So let's go, yeah, it's going to be another loop. Let's go chunks, which is an array of int. Doesn't matter the size. We can just depend on to it. This is going to start at. Oh, it's actually interesting what this is going to be. So this is going to be how many things chunks is going to be. So let's keep our example of 1, 2, 1. Let's keep our example of 1, 2, 3, 1, 2, 3 in mind. That's 6. So this would go between 1, 2, and 3. And with starting at 1, we can do like 6 chunks. Right, so what we're going to do is we're going to go the number of digits. K is bigger than or equal to 1. And K is going to be divided by 2 each time. So, not divided by 2. So if we start at 1, then we go to 2, then we go to 3. Then we would go to 6 times by 2, divided by 2, divided by 2 each time, yeah. It's an even number, so... Well, if it's 8, it's 10. It has to go... If it's 10... Oh, this is, Yeah, if it's 10, we go 1, 2... 5... 10... this is the highest common factor, or greatest common denominator. Interesting. We take that approach for each one to find the size. Now, I don't know how to find that properly. Is there a math for it? Greatest common, no there isn't. This one I'm just fully gonna pull from the internet. So, highest common factor between two numbers. And actually the two numbers... Oh, no, hold on. This is, This is just factors, splitting a number into its factors. So yes, factorize the number. No, it's not this at all because that involves two numbers. Never mind. It's like, yeah, it's just factors. This is if it has 10 digits, number of factors, number of chunks it can do. Am I overcomplicating this? No. Get factors of a number. Golang. I mean, sure. That actually no, that is what you have to do. You can't. There's no algorithm to factor numbers. That's the whole basis of encryption, isn't it? Let's go. Factors of num int. Just list of int. So let's go. Factors make the same. I'm not sure if that is okay or not. Number of factors. Make starting at 0. Return number of factors for I is equal to 1, I is smaller than or equal to num. Actually, like, we can always do, well, I don't care. Actually, that optimization doesn't make any difference. If I divided by, actually, sorry, num divided by I is equal to 0, num factor is equal to append I. So down here, the chunk size, hold on, we have this number, has 6 digits. So 6 we can try 1, 2, 3, and 6. I mean, I guess 1 does work, but 6 does not work because there's no other half. So we can factors without num. So this basically 10 equals 1, 2, 5 without the 10. And we do that by removing that little thing. Okay. So then what we do, so don't take that. We have the number of digits. If it's not 2, do that to 0. Chunk size divided by 2. Actually, I think that can probably go. Let's go factors equal to factors without num. Actually, omit digits. Okay, great. So what I want to try here, actually, let's just think. This gives us a range of chunks to try. We can try, 1. Factor and range of factors. So factor will start with 1 and go with 2. This gives us the number of things we have to do. And we take that by going, so by doing for j in range of, so we're going to start at 1, so we're going to start at the number of digits, right? That's how many chunks they're going to be to start with. Whilst j is bigger than or equal to, so yeah, so for our example here, 1, 2, 3, 1, 2, 3. For example, here we're going to start at 1. Whilst I is bigger than 1, is it? J is equal to j divided by something. Oh, I'm losing it. So the factor, divided by the factor, yes. No, the factor is not going to change, so that if it's 1, that's never going to do anything. Okay, chunk number is actually going to be, it's going to be digits divided by factor. So if digits equals 6 and then factor equals 1, chunk numbers equals 6 for j in the range of 1, or just 0, because this is just going to be a counter chunk, or actually a num of chunks here, and we divide. So we're going to make chunks with ints, and then for each of the chunks we're actually going to, and we could start like this, number of chunks, okay, and we're going to append the, this is where this here comes in. If we have the number 1, 2, 3, 1, 2, 3, we're going to have to just extract 1, and then 2, and then 3. And we're going to do that. Oh, but we're going to do that for every single one, which is kind of interesting. So if we go here, if we think about 2, 1, 2, 3, 1, 2, 3. So it's like we're it's like we're shifting it to the right. Removing the 2, or dividing by 10, So let's do. We're gonna start left to right. We can do right to left. Oh man, drawing such blanks. So to get 1 from here, we're gonna need to divide by this. So the divisor in this case is gonna be power of 10, 5 digits. So 10 to the digits, no, digits minus 1. So 5 plus 10 to the 5. 10 to the 5 is equal to 10. 1, 2, 3, 4, 5. 5, that's correct, I think. Digits. It's not quite digits because we might, what if we don't want to do that and we want to just get the, this, and get 12. Minus j? I don't like this. I'm confused and maybe need to draw a picture. Okay, good. So after some thinking and actually stepping away and, drawing some stuff, I find I cannot think without paper, pen and paper. It's just so much clarity. We are kind of on the right track, right, with the factors here. We start off with the factors, but let's tidy up. Let's get rid of everything else. It's a nice solution, I think. It's maybe correct. We have the factors, and let's just start with, first of all, let's extract this all out into a function called test number. Let's go num ints. That's all we want. And that's all part can run. But we actually kind of want the stuff inside here only. So let's say we have a number. We have the number of digits of that number. And we can get rid of this. And then we can do 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5, 6. That's what I was testing with. Okay. Or actually just this. Perfect. I think we can still return on that. So 1, 2, 3, 4, 5, 6. So here are the capped factors that we still do get. Starting with 1, we actually go from, we take that factor there, and we go I is equal to a factor. Actually, this, I'm going to call this chunk size, which it is, starting at 1. And we're going to go to the number of digits. Yeah, to I smaller than or equal to digits. And I is going to be plus or equal to chunk size. So, yeah, we're going to see in a minute. So if this is 2, for example, we're going to go 2, 4, 6. And that's going to be very important. So then what we do is we're starting off at 2, so we're going to get the lower half of this number, or 1 even. So we're going to get, we're going to do 10 to the power of 1, which is going to give me 6. So 1, 3, let's go. 1, 2, 3, 4, 5, 6 divided by 10. Yeah, okay. So let's go divisor, which is the math at power of 10, and it's going to be chunk size. Okay, this actually works. Yeah, so if we do 10, we're going to get, let's go over here, divided by 10 equals 1, 2, 3, 4, 5, that's 6. And we're gonna just do the remainder, and then we're gonna pull 6 out, right? So we're gonna get mod. Sorry, yeah, we're gonna mod by that. So let's see, the remainder is equal to num mod the divisor, like so. And let's put that as an int up there so it cleans up our calculation here. So let's start like this. Test number. Print line digits. Wait, hello? Can I get? You go here. Why aren't you printing? Okay, you print now. Why don't you print that? Oh, there's no new line. Interesting. Yeah, it was printing. Number of digits, 5? That's not right. Okay, well, there's a off by 1 error there. Okay, cool. Down here, we're gonna get 6, 56, 4, 5, 6. 6, 56, and 4, 5, 6. So you can start to see the magic working a little bit. So actually, printf chunk size, the new line, chunk size 1, chunk size 2. Chunk size, not chunk size, sorry, 1, I. Okay, good. Now we're getting somewhere. That makes a lot more sense. So we have this, which we can, which actually, we still have to like trim, because it should be chunks of 1, so we need to get the 5. This is the remainder. So the remainder for the first one is 6, but okay, that's easy. But there's an extra step here. Whoops. Which is when you divide by 100, you're gonna get 1234.56. Doing the remainder of 100 is equal to 56. So yeah, if you have 56, but then you have to divide by I minus chunk number. So in this case, there's going to be 2 minus 1, but to the power 10 to the power of that. So let's go, I don't even know, remainder divisor. It's going to be the int of math.power of 10 of I minus the chunk size. We'll put that there, and we'll go remainder is equal to remainder divided by math int just remainder divisor, and then we print that, and we get 6543156. Oh, look at that, that's so nice. And now we can basically compare the two, or the 3. So make and 0, and down here we go nums equal nums append remainder. Nice. And then after we do this, let's see what we have here. So at least twice. So basically I have to return any time that this is there. So test number. Cool. Return false, and for n range nums. Let's go previous. Actually, slices dot equal all returns the iterator of index value process. Never mind. Let's just go. If n is not equal to prev turn false, anytime that this does happen, we return true. If it's not equal to that, then we go up here. Let's go all equal equals false. If all equal, turn true. And break. Turn false. Not even sure what this is supposed to do. Is okay. It's okay, false. Well. So anyways, just went to the pub and now want to wrap this up. So this all equals thing is a little bit weird. I don't like it very much. So let's just quickly have a look at what we have with nums. So because we're testing 1, 2, 3, 4, 5. False, false, yeah. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. Let's write that func is slice all equal. Yeah, let's just go with this. If length of s is equal to 0, then that's just true by default. Trivially true, that's the word. Item, let's go s0 and 4. Range of s, we can just check if first item is not equal to I, return false, otherwise return true. Okay, here we go. If is slice all equal nums, then we return true. Okay. So now, basically, we need to test the number there. So part 2, we can actually change that to be part 1 as well, but I'm just gonna leave it for now. I'm gonna go here and say if test number I part 2 plus or equal 1. No, what was it? Adding up all the invalid IDs plus or equal I. Oh, I love how here I could have just used I as well. I'm silly. Yeah, really not with it today. With this part, I feel like I'm better now that I've had some beer, which is always interesting. That's the wrong number. Okay, 11, 22, 19. 10, 10, not. Oh, and 1, 1, 1. Okay, so actually we can't skip the plus. Oof, I don't even know what happens if you do that, to be honest. But it just it just works. Yeah, great, because it just basically checks the 1, and because it's just division. We're not doing any slicing. It just works. Let's remove that restriction. I'd love to add a little article about this. It's probably quite a nice problem. Okay. And let's see. Drum roll, please, because I want to go to sleep. It's actually run pretty fast. Great, cool. Thank you for bearing with me. That was a really strange start to the day. Always go to pen and paper. I need to remind myself to always do that. All right, catch you in the next one.